Good morning, Sumit on this side. So we are going to look into something very interesting, a bit technical though, but very interesting. It's like into my prompting strategy because I've been building something I'm really happy about. I'm building an LLM SDK. This is basically a software development kit as it is known. It's a way, it's a mechanism for your software to use any LLMs. Like in nocodo, for example, I can use any LLMs. I already have that code, but I moved it out to a separate library. You could say it's a library which you can also use yourself to look at code or look at LLMs and then plug into any LLM that you want and then use them. This has support right now for a bunch of large language models. So I have support for Zen as a provider, and then within Zen I'm giving access to GLM and Grok. Both of them, GLM and Grok Code Fast 1, both of these are, by the way, free to use at this moment. And then other than that, there is support for GPT, as in like GPT-5, GPT 5.1 normal, and then GPT 5.1 codex, which is more meant for coding. And then there is Claude integration, Claude Sonnet. The thing about this is that this module was entirely generated by, in fact, actually my entire product is generated by LLMs or coding agents. But the specific example, I'm going to look into how did I generate these last parts, and I have the prompts in front of me, and how do I design with AI, the design documents. By design, I don't mean the visual design, I mean the product design. I mean more the underlying engineering design and how do I do all of those things. So first of all, let's lay out what is the intent of this project. So like I said, it's an SDK, which means you should be able to use any of the large language models which are supported by this SDK. If you plug into this is a Rust based SDK, but I want to create language bindings for Python, Node.js, etc., Ruby, so that you can use, if you are using any of these languages, you can use this underlying SDK and you can use the bindings for those specific languages. All of that will also be code generated, by the way, and we can have a debate about the quality of the code later, but of course this is an ongoing debate everywhere. Right now I want to focus into how do I prompt to add that specific feature which I just added. So within that SDK, the specific feature is that I enable tool calling. What is tool calling? Tool calling or function calling is how, for example, if you have a weather tool, you ask the model to, like, hey, I have a weather tool, it can go and fetch weather data. Depending on the user's intent, you can use this tool. So it's not that the model will always use these tools. It's a choice that the model makes depending on the intent of the user. So if the intent of the user is that, okay, I need weather information at this moment, then the model will, if it deems appropriate that yes, I need the weather tool because I need live weather data or historical weather data. It could be a tool for stock market data, it could be a tool for your physical health data, maybe that is stored somewhere, it may be data from a database, it may be data from an API integration. Any kind of either data that you're fetching or data that you're fetching, or any kind of activity on the computer that you're doing. Maybe it has to write a file, it has to update a document, it has to check your Google Drive. All of these can be done by the model. So the model is orchestrating the different tools that you're giving it, and it's basically allowing that tool to be executed. Let's say we call it execution. So in this example, I'm of course building this at the level of the library, which means any number of tools will be supported, and those tools, and if you remember, like I mentioned, that I want this to be supported also via multiple programming languages, which makes it just a lot more complicated. And this is a territory I have never done as an engineer, by the way. So this shows how I'm able to generate code, and we'll see, if the end goal, end product becomes as good, is that you can get into territories where, oh, I don't have experience building these, but you don't need to. That's what I'm going to look into. That's what I'm going to show here. So let's first see some of the prompts. So the first is the basic prompt of like this, adding this tool. I'm going to get out of Claude, by the way. This is the review of the code. The code is already generated for that tool calling feature, the function calling feature. The code was generated by Open Code, by the way. This is using the Grok model, so Grok Code Fast 1. And as you can see, it has written a bunch of files. We can see the files here in the file viewer, in the file editor, but I'm not focused, as you know, I'm not focused on reading files, or definitely not on writing actual programming files, because that's not what I'm talking about. I'm talking about planning at the very high level, and then enabling like your thought process, your intent to be very clear, and then from there, how do you go to generate code? The generation of the code is generally easier when your planning is easy, or is the planning is good. So let's look at some of the prompts. I'm going to get out of Claude here. I'm going to control C. I'm out of this. I'm going to look at the historical prompts. So I'm going to run Claude again. And this time I'm going to just press the up arrow to get to the first prompt that I'm looking at. Let's see. Okay. Um, this is where I started from. Please read tasks nocodo LLM SDK. This task was also generated by large language model by the coding agent and the Zen provider. Now we have support for multiple providers. So this is where I already had generated support for multiple providers. What does it mean is that the same models, for example, Grok Code Fast 1 is available both through Zen. Zen is a model provider by OpenCode, another coding agent, and it is also available directly by XAI. XAI is x.com, XAI is their company. And so we are supporting two models, the same model with two providers. Okay, so that was already tackled. And then I said, should we tackle tool or function calling? Please analyze. So that's generally how short these prompts are from, like how I'm thinking. It's extremely brief. I mean, sometimes it can be 3-4 lines long. Sometimes it's a bit lengthier, only if I have to provide context. Let's say I have a log, something has failed from either the browser or from the log of the server, and I paste that in. Generally speaking, my prompt, my own language, my own intent is very, very small. Okay, so this is the key point that I wanted to remember. And then it analyzed, by the way. So the analysis document, do I have the analysis document? I do not think I have the analysis document, but I can show you where now I went into more research. The analysis was like, yes, this is a good choice. It also gave me choices of how do I go about it, like what actual technical details in Rust. So what is the way to approach tool calling? Would it be through a derive based mechanism or creating a macro, a proc macro, etc.? So those details were given, and it gave me a choice that the second option, which was I think the derive based option, is the best option. Now these are very technical details and these are extremely particular to Rust itself, but I'm going to avoid those for now in this video. But as you can see, you can ask it to analyze. So that's great. But now it gets only deeper. So we are going to look at the second prompt, which is, so I looked at that analysis, by the way. It was on the screen. I looked at it. I had a glance, and then I thought, okay, I want this to like the tools, list of tools is not set in the library. That's the important part. This SDK is about connecting to different models, but what tools you provide? Do you have weather data? Do you have SQL database? Do you have something else? That depends on you, the consumer. You may be a different business. You may be Shopify, which is using my library. You may be somebody else, and you could combine your existing data, you build your own tool, and allow that to be shared to the model. Which means that this is where this next prompt comes in. Before we start, since this is an SDK, how would a consumer send tools list? Here consumer generally mean consumer of the SDK, and this is fairly clear to the models. Most models will get this without even like trying hard, without us trying hard rather. How do we convert that to API parameters? As in within the SDK there is an API, right? An SDK is an API. There is a set of structures followed in Rust or the other languages that I'm going to eventually support as to how is the interaction going to work out. So there is definitely an API. API is nothing but a contract. It's just a binding contract, right? So you have to follow that API documentation, which means how would I follow it? How do I send my weather tool or my banking tool or something else tool to this SDK? Ideally, you should use Rust's type system. This was also a requirement that I would rather use Rust's type system because Rust has a mature type system for these things. That would keep errors low. Okay, that would also make the structures of those tools, like are you passing, so for weather data, are you passing the city as a string name, or is it like country code with the choice of countries, 2-letter combination or whatever ISO standard combination, and then the city maybe has to be a city code. I don't know, maybe there's a city code central database, etc., etc., right? Is it like an integer city code, or is it like just a city name in string? Those kind of things have to be very clear, because the clearer they are, the less errors you'll have going forward, right? I like building maintainable software. I like refactoring a lot. I like thinking a lot, coming back to it. And this is where I believe that more developers can become more as architects, as people who will think, talk with AI, and get the code generated. So all of this code, like I will show you, there's a lot of code that has been generated in this particular SDK, but it's done only over like a matter of just a few hours. So you're cutting down the coding time, but you are definitely focusing more on the planning time. Uh, that it generated, by the way, more thoughts. And then I also added this extra, um, I would say, requirement, is that we could refer to existing Rust foreign function interface. So FFI is foreign function interface. That's how you integrate one language into another programming language. So Rust may be core, and then Python library on top, or a JavaScript Node.js library on top, or Ruby library, Ruby gem on top, something like that. Okay, so I said, okay, we should refer to existing projects, and it did that. And then what it did was a bunch of these files. So now I can open up these files, because it looked at real world examples, and it started creating these files for me. Okay, and this is where I think it makes it really interesting, because you can now look at these files and you're like, okay, I can sit back, relax, and I can read some of these documents, because it's talking about, for example, and these are very real life examples, Polars. Polars is a well-known data processing library, and you can see, okay, this is how Polars work. Polars is going to have this Rust core, and then the Python module, and then there's a Node.js module, there's also an R-based module. And if you want to dig deeper into how they work, you can actually ask AI to create a new prompt. I would always say create a new prompt, because the context overload is very real, right? You don't want the context from your original feature documentation, whatever you are planning, to kind of pollute this one tangent you want to take, which is like, let's focus into how Polars does it. I would say that would be a separate one. Refer to this document and say, hey, I want to dig into this, or I want to dig into the next project. So the next project it referred to was, let's see. So the number one was Polars, number two was Rough. Rough is, I believe, the Python ecosystem library that is now powered by Rust, which is the linter formatter, etc. Okay, so that again it compared, and I glanced through it. It's very easy to, by the way, glance through all of these things, right? Because I also want to cut down my time, and it's great that it has such nice summary documents that it can produce. You're like, okay, yeah, I see what it does. I see what it does. So all of these have Rust core and a Python or a Node.js or something else on top, right? So then the cryptographic library Blake 3 comes in. Then I see data fusion. I have no clue what data fusion is, by the way. Then the Node.js tooling. So how do some specific Node.js specific? So RSPAC is one, SWC is one, OXC is one, another, etc. How do they work? And it seems like they have very similar patterns. And then finally, it is probably going to give me some kind of a comparison. Yes, it does. So it gives me some kind of a comparison. I'm just remembering, by the way, whatever I had read yesterday. So it gives me some kind of a comparison. How does it work? Okay, multi-language, zero copy. So zero copy is the way I believe how these language to language interactions work. I have honestly never worked zero copy, like I've never built zero copy software, so I wouldn't be able to explain it myself. But that's, I think, the power that I think I'm seeing more and more, is that it allows us to even sometimes know some of these terms just barely good enough to like make a decision, because that's how I am building software. I'm building software just moving very fast, breaking things. That's okay, sometimes things will break, but at the same time I'm trying to create guardrails where tests that are needed. There are, for example, tests that you can look into this library. There are unit tests, there are integration tests, and there is a nice test runner. I can run that for you right now while we are talking. Is that these make life easy. For example, I have all my API keys. I'm not going to open that file, but you can see I'm just pointing to a file where I have these API keys, and then it will run full integration tests, which means it will actually go and make these simple prompts to the system, to the language models, and come back to me with responses and check the responses in the test, like, okay, does it have XYZ keywords, etc., etc. So you can be very thorough in your tests, which means that you only gain confidence. As you can see, the tests are taking some time because they are making actual API calls. So this is how I code. Now moving on to the next prompt, let's say. So this you can see, it created a bunch of, so this is the polyglot SDK design, which is where, how do you approach this whole multi-language SDK design. So it has created a design document for that. The real world FFI examples, I already showed you that. And then finally it came to a tool calling decision. So this is the very high level tool calling decision. It has the design document, the comparisons, the multi-language comparison, all of that finally poured into a design document. And then finally I go ahead, I read this, I understand what it's trying to say. It gave me multiple options. I was like, okay, I will not have these options in the actual task file. And then let's create a task for this in the tasks folder. So I have a tasks folder. I'm going to show you the actual task file. Please only include the derive based approach. I see, like I said, it had multiple approaches to designing this, to building this. Mention the future multi-language, the future multi-language we need, the multi-language method, right? The multi-language rather requirement we have, that there'll be Python library on top, Node.js library on top, etc. And then share technical detail, technical context and examples, but do not link to the other documents which we created for our research. Remember, I'm basically converging them into one task. The task should be clear, all the research has been done, I have looked into it, I'm combining all of them into one task file. That task file has to be precise, compact, so that I can now hand it over to another coding agent, in this case OpenCode with Grok Code Fast 1, because I don't want its thought process to just go haywire. Oh wow, this is a lot of research we are doing, I don't know what I'm doing, right? That should not happen. You have to converge that back into one clear, let's say, prompt. And this is what that prompt looks like. Now if you open the task file, this is what it actually looks like. Implement tool function calling for nocodo LLM SDK. This very clearly says, okay, what is the status? Add type safe tool or function calling support to nocodo LLM SDK using the derive based approach. See, it has specifically used derive based, no other options given, right? With the JSON schema generation, this enables agentic workflows where LLMs can call external functions, blah blah blah. This document, we can read through. By the way, all of this source code is available, all of these documents. I think the research documents maybe I will not keep in Git, but everything else will be, which means the task files, all these task files are actually, this is a habit that I'm also building. They are available for your reference if you want to go ahead and look into some of these, how I generate the task files. The prompts I'm going to also showcase at some point through nocodo, like in the software itself. So it helps others to build software the way I build. And by the way, my way of building is nothing fancy. It's just how software engineers naturally think. I mean, software engineers who are embracing AI coding or agentic coding heavily. I think it's very natural for us to come to this point the way I go. Okay, so create a bunch of research documents, look into existing software, do references, create documents, and then from those documents create the actual task file or the prompt that will finally go. And then the real prompt that I finally send to OpenCode is just this. Okay, so sorry, this is just the combination of colors, which is just weird in this screen, but I can copy this line and I can show it to you. This is how easy it is. That's it. Please attempt tasks / the task file, and done. We are done. This took it about maybe 40 minutes. Okay, these are the number of files it modified as it is showing on the sidebar. This is OpenCode, by the way, not Cloud Code. Cloud Code is for my planning. And then finally I ask it to review. As you can see, let's go ahead and review this. Look at this review. So it goes ahead, it reviews it. Again, the reviewing is also following the same pattern. If you look at my prompt, hang on, I can show it to you here. If you look at my prompt, you'll see that this is where did I start? We worked on, we worked on same task file. Please review the work. That's it. It has already started seeing that there are some issues, minor issues. Okay, it fixed them, which by the way should not happen. To be honest, you can keep review process and fixing process separate. You can make it very explicit. Please do not change any code, just review. So I don't usually do that. I allow it to change code. It's fine for me, but you can go either way. You can be as precise as you want to. It's all in that one simple prompt. And then it reads the task file. Remember, it reads the task file, so the context will expand immediately, right? It will get all those details. And then finally, perfect. Now let me provide you with a comprehensive review. according to the review, it says, okay, what has been built. It has looked into the actual Rust types that has been generated, blah, 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 all those files that have been modified, blah, blah, blah. And then finally, it has also seen, okay, there is a simple weather example, which is awesome, which is great. So if I look at the source code, there is an actual weather example. So it has created a dummy weather related, hang on, let me see where this is. I think it's in the tests, tool calling integration. Yeah, weather. See, this is where it has created a dummy weather, let's say, tool. Okay, it is asking OpenAI, GPT-4o in this case, it is asking to give me response for a given, like get current weather for a location. Okay, so there's a simple prompt, and then it is basically seeing, it's going to see if tool has been called or not. So get weather tool has to be called. If it is not being called, then the task will fail, then this test will fail. So as you can imagine, taking a step back from all of this, this is how, now let me give you the final git. This is the important part, git status. This is the total number of change. I'm not kidding. This is the total number of change. It's a big change, and it all got done because I'm not touching code. It's just planning, looking at all this documentation, researching, putting them all down into one task, handing it over to a coding agent. By the way, I mix these coding agents simply because the costs are low. I'm using only one pro plan with Claude Code, Claude Pro. Okay, just one pro plan. So I do only my planning on it, and I do not generate code. Remember, your output tokens are costlier than your input tokens. So it's okay to plan. You take a lot of things, put them all together. The output tokens has to be lesser. So if you are generating just a few research files and then finally converging them into just one task file, that's great. And then I shift over with that precise task file into a cheaper coding model with a cheaper coding agent. I can use GLM 4.6 or I can use Grok Code Fast 1, and that gives me really high quality code. Job done, right? I hope this video was interesting and useful. If you have anything that gets stuck, just let me know. I'm happy to help. Reach out to me on Twitter, LinkedIn, anywhere you can find me, or I'm also available on Slack, on Discord, on a few channels. So yeah, have fun.